all together, also from my side. My name is Christian Ochs, responsible for additive manufacturing in a totally different industry. We're talking about railways now. And we from Siemens deliver rail systems to our customers. These systems contain of the infrastructure and the intelligence, of course the trains, starting from subways, trams, up to high-speed trains, and a service and spare part promise over the whole lifetime. And all of you can imagine railway systems are high cost and long-term investments. So it is crucial for our customers that the systems are 100% available. Of course, there is no 100%. If you have planned maintenance, you need backup trains. If you have an accident, you need to have a backup train to be able to run the schedule. But we want to minimize this number of backup trains to a minimum. And this is what we call 100% system availability. So who of you came to Berlin by train or any means of rail transport? Please raise your hands. Great. So not only very sustainable, but a lot of practical experience in this room. Perfect. So please imagine for a second, you are responsible for rail service and spare part supply within Siemens Mobility. Then you would have to overcome some challenges. First, and really very challenging, is the very, very long lifetime of our systems. The trains are designed normally for 30 years, but it turned out they are in operation easily up to 50 years. The infrastructure easily doubles that lifetime. So you would have to supply spare parts to the customer, reliable, on time, anytime. And now I think you see the challenge. This is not so easy because suppliers change, especially when you have a worldwide distributed supply chain. And we are doing this since quite a while, so we have a big installed base with many different vehicles that were customized to our customers' wishes. So we have a very high variety and compared to Daimler Truck, quite small quantity. And in railway business, you're always facing high cost pressure, of course. And at Siemens, we set ourselves high sustainability targets, and do our customers. So these points, on the first look quite like a perfect match for additive manufacturing, and that's why we started 10 years ago, our activities. But then it turned out that in the railway business, you do not just have these challenges, you also have very sophisticated standards and norms, and you have a lot of regional differences between countries. So what, for example, works additively in the US does not necessarily have to work in Europe or Germany. So how are we doing it? I try to give you an overview how additive manufacturing at Siemens Mobility supports this 100% system availability. And I would try to continue with the standards and norms. They make it very hard to change a conventional spare part to an additive one, especially when it's safety related or safety critical. We overcome these obstacles in the past, but it was high effort and took a lot of time. So one R&D topic in additive manufacturing in the railway industry will remain making this process faster and of course cheaper, to come to more economic use cases. And to do this, we are not working alone. We are collaborating with our big customers, like for example the Deutsche Bahn. We have to collaborate, of course, also with the authorities and, for example, the TÜV Nord at that point. What other R&D topics have we done in the past and are continuing to do? Of course, we are checking the market for new printer technologies all the time, but they have to reach a very high maturity level so that we can use them. And we are working on design guidelines, additive design guidelines, but customized for our engineers in the railway industry. So when you are producing metal and polymer parts in the additive way, like we do it in-house, for railway industry, quality is king. Especially when more than 500 people are sitting in a high-speed train on their way to Berlin to visit the AM Forum. Nothing should get defect there. And that's why we put a sophisticated quality assurance system in our worldwide printer network in place, because we are producing end customer parts locally all over the world to avoid transport distances. And so this is really very important for us. Now I'm coming to the right side. We are combining this additive know-how with our train engineering know-how. And when a spare part is needed and conventionally no longer available, there is normally a reason for it. Be it obsolete, so no longer available, or be it maybe just worn, or be it overloaded, maybe as a result of an accident. And when we are then doing an additive redesign, because we maybe not match the material and we're changing the technology, we are always trying to bring in some additional values for our customers. And we call that innovation in the spare part, Sparovation. So our service here is called Easy Sparovation Part. But we are combining the physical world, although with our digital solutions. So if you would be a customer of us, you can go to mymobase.com and create yourself an account like on Amazon, and then start ordering spare parts for the railway industry. And of course, you can order your customized additive spare parts over that platform as well. The platform is linked to our ERP system, so the billing can be done, and connected to our virtual stock. Another important digital use case is the identification of parts for the technicians that are working in the depots, or on the track. Imagine a 50-year-old part, not so easy to find the part number, and we offer a service to scan the part or scan the part number. Then you cannot make mistakes by writing it down. And then out of the app, it can be directly put into the shopping cart of the Mobase and ordered. So let's get a little bit more specific. Besides the spare parts use cases, we are also doing some others. But let me continue with spare parts. There you see a tram, and the side skirt was, in COVID times, no longer available due to disturbed supply chains. So we did an additive redesign. We segmented it in two parts, and this has the benefit that just one part can be exchanged in case of an accident, which very often happen between trams and cars. On the lower right side, on the first look, you see two different vehicles. But it's the same vehicle. We just exchanged the front apron and changed to LED lights that were overtaken from another vehicle type the customer is using. And by that, totally changed the look of the vehicle. We modernized it. And we did this in a co-creation together with a customer. And a benefit is stock levels are reduced. On the lower left side, you see an example for additive use internally. So of course we're using it for our purposes as well. And Borussia Dortmund was playing on a Saturday, and then after the game the fans were enthusiastic, traveling home. I don't know what they did, energy loaded, making some pull-ups maybe at the overhead compartment, and everything came down. In the depot was analyzed what is defect, and it turns out a big carrier lost a small edge. So normally you would exchange this big aluminum carrier by a new one, but this was not intended, so we didn't have it on stock. So what we did is we created a new, smallest repair unit via selective laser melting, which now can withstand 2.5 times the load, and brought it to the vehicle. Benefits: 95% less material consumption, and of course less energy consumption as well. On the upper left side, people are always asking me, Christian, are you doing also serial production? And the answer is yes, of course. Yeah, we understood that this makes sense to bring the parts into the vehicle right from the beginning. And the example here is a nozzle which has 5 times the performance a conventional part could reach and is 70% lighter. And we are producing it in powder bed fusion by laser, over 100,000 pieces. So now, to sum it up, I told you we are producing in a printer network with high quality standards that was implemented over the course of the last nearly 10 years. We have a lot of experts in our team and on the locations, and have a virtual stock in place and an order platform to make it convenient to order parts. If you want to deepen the discussion, please feel invited to our booth I02 and meeting with our experts Stefan Landkammer and Sebastian Katona from my team, and also the Digital Industries experts to talk about their solution, like the AM network, to organize the collaboration between printer locations. Thank you very much for your attention.
I think the applause is for all three of you. Fantastic presentations, and we have a bunch of questions we want to answer here in this auditorium. And the first one goes to Matthias. That was one question I had too. How did you identify the 40,000 spare parts that you selected for additive manufacturing?
With hard work. No. Of course, we started small, start with simple geometries, or do a first selection of the raw material, for example. If I know I have a conventional and ABS, maybe I could substitute it through a PA12, for example, and this is the first shot. And then you go more into detail, and in the best case, you use a little bit of AI to do it on an automated way, and this is how we proceeded this.
Okay, very good, very good. Christian, how do you consider the business case of such a spare parts, considering that some of them are critical? Are you printing critical parts as well already?
Sorry, I didn't.
Critical parts already, safety critical parts?
Yeah, we did that, but as I said, it was really high effort.
Okay.
So we are still working on making this process faster.
So how do you do the selection on the parts? Which one you're going to choose?
Of course, we scanned our inventories to see if there are parts that fit better to be produced additively. I have to admit it is a challenge because all these parts in the past were designed for conventional manufacturing, and I think you mentioned it in your presentation when you are just exchanging them and printing them one by one. Now additive, the costs are normally higher. Yeah, so you have to take into account additional benefits, like stock reduction, or in our case, often avoiding of penalties when the vehicles would have a downtime because of a missing part.
Very good. But there's a very interesting question that came to my mind. So you sell it and somebody else is printing it. How can you prevent that it's not printing one time, but 200 times?
We developed with some partners sort of digital rights management, and it's a little bit tricky because you have to put some software, additional software, into the printer of the printer manufacturers. It's a little bit depending on the printer manufacturer if he's willing to do so, to give us access to this machine. And luckily we find some of them, and so it's part of the software. I cannot explain in detail how it works technically, but I know there's like a counter, and if the customer pays for a one-time print, then he can just print the part one time. If he pays for 100 parts, then he can print 100 parts.
Okay.
And one in addition, what was very important for us is that the customer is not only able to print our licensed parts solely, because he can mix it in the building chamber with other parts that where we don't have the IP. So for example, he can build some fix and jiggers for his workshop and spare parts on the same time.
And one additional question that came up as well is how can you ensure the quality if you do not have the printer that is printing that out? How do you make that sure?
It's not plug and play. So they say, oh, I bought a printer and now let's get it started. Of course, we have quality issues, and the customer that wants to print parts himself has to do a kind of qualification of the printer if his printed parts meet our quality standards and requirements. And if he gets this certificate from us, then he's allowed to print the parts by himself.
Okay, so first certification, and then you can do the print. Marcus, I mean, a question for all of you, but probably you can answer that. You are looking for feasible parts, okay? How do you select the ones that are the right ones? How do you do that?
Our business is totally different. MT Aerospace has design authority for the structure of the Ariane 6, for example. So we have the engineers in-house, and these engineers are more or less looking for potential parts with the knowledge of the demands on the parts, mechanical characteristics and things like this. And a spare part business as you have it is not in our business plan included. Of course, if anyone is coming to us and asking for a part, can you produce a truck part or whatever? Of course we can do it, but it's not our business at the moment because we don't have any contact to these demands.
I mean, we are not talking about hundreds of Arianes that are being produced every year. What is the volume we are talking about when talking about your AM production? How many parts do you do per year?
Of course.
How many parts do you do per year?
At the moment?
Yeah.
Oh, it's different. Our parts are much bigger than the parts we are talking here. So we are producing at the moment about 5,000 parts per year.
Okay, very good.
But one part has roughly a average building time of 100 and 120 hours.
Ah, okay, okay.
It's different to the business we are talking here.
Yeah, very good. Christian, I mean, there's not only printing, there's post-processing. And if this is decentralized, how do you organize that and ensure the quality then with the post-processing?
Yeah, this is, of course, taken into account in our quality assurance process as well. And for example, one very tricky process step after the regular AM finishing of a part is the coating process. Why is it so difficult for us? Because in railway industry we have very high flame retardancy demands and standards. Also in terms of toxicity when the parts catch fire. And therefore we had to develop by ourselves a coating system for the exterior parts and also for the interior parts. Got that certified in tests, and we qualified a few suppliers to do the coating process to our needs. And this is more or less one important thing that we do.
And Matthias, how can I imagine that? So let's say I have a big fleet of trucks running on, or buses or whatever, running on the streets all over the world, let's say. And now one of them has a defect, and one of the parts that I would need is out of your digital warehouse. And let's say I'm in the middle of nowhere. How do I get to this part? What is the process behind?
If we don't have it in a digital warehouse, then you can contact us. We have through our service organization, and we take care that we do some re-engineering, for example, to make this part printable and print it as soon as possible. Because it's like a little bit of our own interest, because we offer our customers 100% vehicle availability, and sometimes we have to pay like a penalty fee, for example. And for us, it gets a really positive business case if we say, okay, let's do some re-engineering, and I don't care if the part costs twice as much. The vehicle has to be in operation because they have to transport people or groceries, drugs, whatever.
Very good. So I can imagine the future is really like I'm standing anywhere, I call my partner, the service partner, and he says, we have it in the warehouse, then we print it, they bring it, or...
we see an additional benefit to the existing service organization because we don't have really big white spots, but from the classical distribution structure, it can be that this truck comes to a service partner and he also doesn't have the part and he doesn't have a 3D printer, but 5 kilometers next to him there is a printer provider, and so we say, okay, go to this printer provider, get your part there, and we get service on the vehicle.
Okay, very good. Christian, you mentioned that you modernize the vehicles with the 3D printed part, and we saw some, let's call it visual modernization or upgrading on the visual side. Are there any, let's say, technical parts that has or functional parts that you are optimizing on in this process? Because you have really long lifetime, so probably a way to not on the software but on the hardware side upgrade the vehicles over time. Is that something that is already happening?
Yes, of course it's happening. Let's stay in this tram example. Trams are usually going over a total overhaul after 16 or 18 years of the lifetime, to start the second half of the lifetime. And in this process, you are nowadays, of course, bringing in a lot of new monitors, a lot of new air conditioning systems, which are far heavier than the previous ones. But the vehicle is homologated, so the total weight and the weight of the distributed over the axles does not have to change so much. And therefore, when we can bring in parts like this facelifted parts, they are in addition, for example, also up to 50% lighter than the previous parts because of the intelligent design that we do. And this helps in this overhaul use case, of course, a lot. Because if you would have to make a new homologation, it would cost a lot of money and take time.
Very good, very good. One question for you. How important is sustainability in producing the parts? Is that something that is addressed to you from your customers or inside the company?
It depends on in which area you are working. In prototyping business, the stability is very, very important just for the lead time of the parts. And you need just a machine which is producing the complete job in one run. In the business we are working, we need a stability on all characteristics of the machine, not only a breakdown or not breakdown. So we need the stability of the laser, a stability of scanning system, a stability of the material. And all these topics we are at the moment far away from a result. I have a background of now 15 years AM printing, thousands of jobs, and my average breakdown rate is at roughly 10%.
Okay.
If you're selling a machine, like a milling machine, and you say your customer, you will have a breakdown time of 10%, no one will buy these machines. And in the area we are working, this is accepted. And that's why we did hundreds of changes on these machines just to get a quality check what happened with the machine. This is all external of the machine. Because the quality we get at the moment is not suitable for the business MT Aerospace is doing at the moment.
Thank you. Last question to you, Christian. I mean, in the past, I mean, the beginning of, let's say, introducing it is due to the need of the long lifetime and the spare parts needed for the current vehicles that are out there. But I think it changed. It's now contractual, right? I mean, if you want to supply vehicles in the future, they expect from you to guarantee a certain lifetime for the spare parts. Is that pushing AM a little bit more in your area?
Yes, of course, it does. And because supplying in the conventional way would mean you have to build up stocks. And then you have a lot of capital bound in it. The Deutsche Bahn can, I think, confirm they have a lot of money bound in their stocks. And the target is to reduce this. And therefore, additive helps a lot to be ready, to have the capability to produce parts in the case they are not needed and not available anymore, or in case it makes sense from the beginning. Yeah, so when we are now developing our next generation of trains, yeah, we are really scanning where can we bring in additive parts right from the beginning, to really use the design freedom, for example, that comes with additive.
Very good. Matthias, last question for you. It's about money, and I do like the money questions. So you mentioned the price differences and that you have to have a holistic approach in observing the prices. But what is the price differ or the cost differ if you buy a usual spare part or later on an AM spare part?
In our organization, the price is the same.
Yeah?
You always pay the same for the conventional as for the 3D printed part. The licenses that are much cheaper than a printed part.
Okay.
No.
Very good. Excellent. That was very good. Thank you so much, the three of you, for being our guests. To have very interesting insights, to be honest, in something that we consider as one of the future main topics of additive manufacturing. So it was exciting to hear you. Thank you so much. Have a great conference. Okay.
Thanks for having
Thank you.
us.
Thank you.
Ladies and gentlemen.